Hey guys, welcome to 3.4 Concavity and the Second Derivative, Part 2. In this lesson, we're going to go ahead and complete the examples. In my first video, we just pretty much talked about what it means to have a concave up curve, which is a cup, and a concave down curve, which is a frown. Okay? And if you have a graph that goes from concave down to up, that means that you have a point of inflection. Or concave up to down, you still have a point of inflection. These are called your poise. Okay, now let's go ahead and use what we've learned on the previous video to do this example. The graph of f is shown. This is f. Not f prime, not f double prime, but it's the f. State the signs of f prime and f double prime on the interval from 0 to 3. So all we need to know is f prime greater than 0, less than 0, or equal to 0? And the same thing for f double prime. Now, what does f prime stand for? It stands for the derivative, which means the slope. F double prime stands for concavity. Let's go ahead and take a look at the slopes of this function. Even though that we don't have the derivative, we can determine the slope. If I were to get a point here and try to draw a slope, I would get what kind of slope? Positive or negative? It would be a negative slope. Let me draw that a little bit better. Negative slope. What about here? Negative, but is it more negative or less negative? The answer to that would be less negative, which means that the slope is increasing because it's becoming less negative again, and then less negative again. So all of these slopes are negative, which means that the first derivative is less than 0. Now, what about the second derivative? There's two ways you can do this. The first way, the easiest way, is by looking at the concavity. Is this a concave up or a concave down? And you'll notice that it's a concave up, which automatically tells you from the definition, concave up means the second derivative is greater than 0. Now, if I go back, oops, sorry, I don't know where I went. Okay, here we go. If I go back to my slopes, I notice that my slopes are not decreasing. They're actually becoming less and less, which means my slopes are increasing. They're increasing because they're becoming less negative. So another way to say this is because my slopes are increasing, my second derivative is positive. Or you can just stick with the concavity part of that. So those are the answers for example number 1. Example number 2, we have a function, and what we want to do is we want to determine increasing, decreasing intervals, max and mins, concave up, concave down, and points of inflection. So let's go ahead and do letter A and B. Letter A and B kind of go together. Increasing and decreasing, which means I first need to find my critical numbers. So first find my derivative, and that is 4x to the third minus 12x squared. Set the derivative equal to 0. And I should factor and solve. And I get x is equal to 0 and x is equal to 3, and those are my critical numbers. So let me go ahead and draw a number line from negative infinity to positive infinity. This is f prime and this is f. And I have two critical numbers. I have 0 and 3. These are my critical numbers. And I want to go ahead and choose negative 1, 1, and 4. And now I'm going to plug those numbers in to my derivative, which is right here, f prime of -1. Determine the sign, and that is f prime of -1 cubed minus 12x, 12 -1 squared, which is -4 minus 12, and that is negative. So this is a negative, which means that it's a decreasing slope. Sorry, not decreasing slope, decreasing function from -infinity to 0. Let's test our other value, f of 1, which is f of 1, 4 times 1 cubed minus 12 times 1 squared, and that is 4 minus 12, which is also still negative. So now here's the example where I told you guys that not all the time will you have increasing, decreasing, alternating curves, alternating intervals. Now you have both of these to be decreasing and decreasing. Okay, now the last one is 4. 4 times 4 cubed minus 12 times 4 squared, and that is 256 minus 12 times 16, which is positive, and that is a positive slope, which means it's increasing from 3 to infinity. So doing letter A and B together, A, f is increasing on 3 to infinity because f prime is positive. F is decreasing on -infinity to 0 and 0 to 3. Notice that I had to split off the intervals. I can't say that it's decreasing from -infinity to 3 because this is a critical number, and that means that my derivative was 0 and not negative. So I got to split it off because f prime of x is less than 0 or negative. That's letter A. Letter B is my relative max and min. F has a max. Oh, I don't have a max. I just have a minimum, right? F has a minimum at x is equal to 3 because f prime changes from negative to positive. This is a minimum. Okay, now letter C. We want to find the intervals where f is concave up and concave down. Okay, so to find concavity, we need to find a second derivative. We need to find f double prime. So if this is f prime, if f prime is equal to 4x to the third minus 12x squared, then f double prime is equal to 12x squared minus 48x. Now if we go back to our definition of concavity, concavity means that the derivative is increasing, which means that the second derivative is positive. And if the derivative is decreasing, then that means that my second derivative is negative. So I have to determine where my points of inflections are, which means by this definition, a point of inflection is when the second derivative is equal to 0 or undefined, but it's not enough for me to determine if they're undefined or 0. I also have to check to see if they even switch points if they even switch concavity. So I had to do another number line test, but for second derivative. But before I do that, I set it equal to 0. So 12x squared minus 48x is equal to 0. And then solve. So it's 12x x minus 4 is equal to 0. And I'm going to go ahead and stop the video right here and continue on the next video.